electrical pros.
Easy, easy. It's not that hard. Trust me.
What do you mean it's easy? Look at all these damn knobs.
But there's only one knob.
Oh.
I'll show you. Just come on. I'll take you over here. I'll show you.
You're gonna show me to use this? All right.
So this is part 2. I want to go a little bit over some things I didn't go over in part 1, some things I said I was going to. So I wanted to go a little bit more in depth about using resistance, because last time we just sort of checked continuity and we were mostly looking for open or 0 ohms or, you know, continuity. That's another thing when somebody says, you know, is there continuity? That means 0 ohms or generally less than 10, I would say, is pretty much continuity. So we're going to go back to the meter here, like we talked about in part 1. You're going to set your leads up with the black into the common, and the red into the resistance setting, or using ohms. So what I have here is just a 10 ohm resistor. So if I wanted to use the meter to measure the resistance of this resistor, I would take the leads and go across both of them. And we can see on the meter that we get 10 ohms. This is a 10 ohm resistor, so we get 10 ohms. Now, the other thing to remember is when you measure resistance, if you measure it this way, you get 10 ohms. If you measure it the other way, you also get 10 ohms. If I can get that poked in there. Right? So when you measure voltage, it has to be specific, like you want your black on your negative and your red on your positive. You can do it the other way, it just shows negative, but I'm not going to get into that. So why are resistors important, or measuring resistance important? So the point of a resistor or resistance in a circuit is to drop the voltage of a system. So if you have a 12 volt system, like let's say, let's go with panel lamps, like your dashboard lights. I'm the type of guy, I like them dim. I don't like them really bright, so I definitely need one of these. It's a resistor, it's a variable resistor. This goes in the dash on this truck, so I'll show you. Come with me. So we got little black Pete here. I pulled this out of the dash. This doesn't work, and one good clue why you can tell it doesn't work is because the bolt was taken out of it, it was shoved in the back of it. So it was just on the dash here. I don't know if you can jump up in here or not. And it was just labeled panel lamps in here. And this was like this behind there, and you could turn the knob to adjust it, right? Sort of like you would do on this. Anyways, so the point of this in the scheme of panel lamps is to drop the voltage to the light bulb. So if you put 12 volts to a light bulb, it's very bright. If you put 3 volts to a light bulb, it's very dim. And you can kind of vary it in between, you know, 3 volts and 12 volts. I mean, a light bulb will work all the way down to pretty much nothing. It'll just be very dim if you can do that and, you know, sort of see it. Like if you kind of have a dimmer switch in your house, you can bring it really low till the point it's almost off. LEDs don't really work that way. They get below a certain voltage and they just shut off. Anyways, so you can check resistance across this. If this one would work, which this doesn't, is we have 2 wires, just like the 2 poles on this, goes to this connector. And you can put 1 lead across there and 1 lead across there. Okay, next thing I want to talk about is these jumper wires that I have so nicely displayed out here. That one's no good. This one's just... So you can get a set of these off of Amazon for a few dollars, less than 10. They come in packs of 5, 10, 15, something like that. They're very cheap and they're very nice to work with, especially inside of something when you have to, like what I was just trying to do there is like hold this in here, and it's tough. So what you can do with these is just clip them onto there, and then like I said, either one will work for measuring resistance. Put it on there and it reads that, right? Now this should vary the resistance when I turn this knob, and it doesn't. So clearly this is broken. So if you have like dash lights that don't dim and you might think it's your dimmer switch, you can hook up your multimeter to it and measure to see if it changes. If it doesn't change like this one is broken. Now this is the same thing here. This is a potentiometer, which is the same thing. A potentiometer, variable resistance, resistor, it's all the same thing. So you can both see they have knobs on it and they both turn. This one has 3 leads, this one only has 2, but they both work the same way. So if I hook this up to the meter, right, so I have 1 lead goes to the red and 1 lead goes to the black. You can see we have 12 kilo ohms. And as I turn this switch, I don't know if we can see this on camera. Let me bring it over so I can see it. You can see that the resistance will change as I turn this. And also, like we talked about in the last video with this bar, you can see that the bar goes up with the resistance. So if I turn like that, you can see the bar moves. I don't know if you can get that on camera or not. You get a little bit of a shadow there. Can you see that? Yeah, so we go down, go up, go down, go up. So that's one potential use from using the resistance setting on your multimeter. Another one that's pretty important is to check sensors if you think a sensor's not reading right. So a couple examples. I just grabbed some temp sensors because I had them laying around. This is an intake air temp sensor for a Detroit 60 series. This is a CAT temperature sensor. I'm assuming that's water temp, but I'm not real sure. Anyway, they all kind of work the same. They work the same as this variable resistor, but rather than you having to turn it by hand, the temperature of the water is actually what's turning the knob. So when you see I'm going to heat up the end of the sensor, it's acting like this knob is being turned, and that's how the ECM gets back what temperature means what. So I'm going to put a chart up here in post-processing, or Jordan's going to. So each resistance setting is going to represent a different temperature. So in this case, on this one, well, let's just hook our meter up here. Now this coolant is probably room temperature, probably 70 some degrees, something like that. So we are going to hook our leads up. We have a visitor. So we hook one lead up to the one side, and we hook another lead up to the other side. We can see on the meter that we get 1.13 kilo ohms, right? So 1.13 kilo ohms represents, in this case, probably 70 degrees, right, of water temp. The ECM will actually run a voltage through there, much like it runs, like the panel lamps run a voltage through this, and the voltage will drop across it. So if your panel lamps run 12 volts through this, and this thing drops it down to 5 volts, then that's how you get less bright bulbs, like we talked about before. So on this one, we can see it's 1.14, and I'm going to take it out and see if I can get this to light. And I don't know if Jordan can see the meter or not. Does that shadow help or no? Alright, that's better. And as you can see, I'm going to heat up the sensor, and you see the resistance is going to change. Right? And then as it cools off, you can see that the temperature or the resistance is changing. That's how the ECM sees what temperature it is. So if you have a bad sensor, or a sensor that doesn't read right, like I had one a couple weeks ago that it was an oil temp sensor, but it didn't read right. When it was plugged in, it would read like 210 degrees of oil temp, and the truck was sitting there cold. So obviously the sensor was reading wrong. In that case, internally on the sensor, there was something bad inside which was making it read wrong. So that's one way you can use a multimeter to help diagnose your truck. Alright, so in this part of the video, we're going to go over current draw. This is the test you would do if you had an issue with your truck going dead maybe overnight or in a few days, or sometimes you let your truck sit for a week, you go to start it back up and it won't start. So what that means is your battery's here have so much energy and they'll last for so long without being used. If you have nothing on here and there's no current draw, these batteries will last a long time. If there's a current draw on it, they won't. So we're gonna do a test to see how much amps this truck is drawing. But first I wanted to go over a couple things here. I haven't touched any of this yet, but you can see back here, we talked about this in this first video about checking your battery connections first. This one is loose. I grabbed a hold of it right before we grabbed the camera, and this is finger tight. Like, that's going to cause a lot of issues. This one also looks like not very, looks terrible, and it's also loose as well. So you definitely want to make sure stuff like that is tight, and if you're having any sort of weird electrical problems, like I said in the first video, this is a good place to start, just even checking things like that being loose or this being pretty nasty. It's a good start. So in order to check current using your multimeter, and if you want to jump down here. So in the other videos, when we check voltage or resistance, we want to have the black on common and the red on voltage or resistance. When we check amps, we want to use these ports over here. Now my meter has a 10 amp max on this port and it has a 440 milliamp one on this side. So most meters have a 10 amp fuse, meaning if you exceed 10 amps, it blows the fuse inside, which is repairable on most meters. You can change the fuse out if you blow it. So keep that in mind when you're checking something. If it's less than 10 amps, you can use a meter. If it's more than 10 amps, you're going to need probably some sort of different equipment. So if we're going to check amps here, we're going to take our leads. We're going to have the black one in common, and I'm going to put the red one in 10 amp max. All right. Next thing we need to do is we need to put the leads inside the circuit. So when we measure voltage, we go from the negative to the positive and measure voltage that way. When we measure resistance, we go across the 2 points that we want to measure as far as resistance goes. If we want to measure amperage, it has to be in the circuit, meaning current will flow through the meter and actually give a reading. In this case, I said in the last video that doing a resistance test does not complete the circuit. This test will complete the circuit. So we grab our West Virginia socket set here to take off the battery leads here. All right. So we can see here there are no more battery connections. The whole system should have no voltage on it. The test is you open the door, you don't see any lights coming on, like the dome light or anything like that, no door lights. There's no voltage in the system. So now we take our meter and we want to turn it to amperage. So in this case, on my meter, it's all the way over to here. Same thing with the DC or AC amps going to this system. All right, I'm going to just change the range on this, make it a little easier. It triggers JR. Alright, so then you want to put your black lead on the negative. I'm going to actually get my jumper wires here. This makes this a little bit easier. Because I'm lazy and I don't like to hold the leads. So, alright. So right now, with the door closed and everything, this is drawing 0.25 amps, or a quarter of an amp. Now, you can do some checks, like you open the door, that light turns on up there, and you can see now we're drawing 1.8. So that light up there is drawing 1.6 amps. We shut it, we go back to a quarter. Now, when I check for amp draw to see if somebody's having an issue with how long, like my truck goes dead in a few days, I usually like to see less than like 100 milliamps. So in milliamps, so this anything left of the decimal point here is amps. Anything to the right is decimal places. So this is 245 milliamps. I like to usually see less than 100 or like 50, 80, somewhere like that. So it would read 0.08 for 80 milliamps, 0.100 for 100 milliamps. Now, I mentioned earlier about having storage capacity of multiple batteries. So if you want to know how long this truck would last at this voltage or this amp draw, we can actually calculate that. And Jordan will put some nice graphics on the screen. So what you want to do, on most of these larger batteries, they don't have the spec in amp hours, they have it in reserve capacity, which if Jordan can see on this battery, it says right there. Let me know when you got it. I guess I should get the right figure. Okay, so this is 195. I don't know why they don't put the minutes or the unit on it, but it's in minutes. So what this means is this one singular battery will do 25 amps until the battery voltage gets below 10.5 volts in 195 minutes. So it will do 25 amps for 195 minutes. Then this 12 volt battery will drop to 10.5 volts. I know that was a little confusing. So if we want to calculate how long this is going to last, we're going to need amp hours out of it. So to reverse this number, or convert this number into amp hours, we need to take 195 times 60 and then times 25. Actually, just cut that part out. All right, technical difficulty there. So yeah, we want to take 195 minutes times 60 to convert it into seconds, and then we want to take that number and multiply it by 25. So if I get my calculator out here on my phone, we're going to do 195 times 60, gives me that number, and then I'm going to multiply that by 25. Now with this number represents the coulombs or units of charge in this battery. So if we want to convert that into an amp hour, so amp hour just simply means, like if you have a 100 amp hour battery, that means it will do 1 amp for 100 hours. If you have a 200 amp hour battery, it'll do 1 amp for 200 hours. So if we want to convert this, we need to divide it by 3600, and that gives us 81.25 amp hours. And we have 3 batteries. Now, when you have batteries that are wired in parallel, like this one with all the reds tied together and all the blacks tied together, you would add the amp hours of every battery. So these 2 batteries are the same, this one is different, but for this sake I'm just going to assume that they're all 81.25 amp hours. So I'm going to multiply that by 3, since I have 3 batteries. So I have roughly 244 amp hours. Now, there is a website, I don't know if Jordan can go in this, you can just type in battery runtime calculator, and you see I've already ran this a little bit. So this is a lead acid battery. When it says battery type, I'm going to select lead acid battery, and capacity of these 3 batteries I just assumed was 250, and the application consumption, which is what our amp draw is, 0.24, or I just put 0.25. We hit submit, and it gives me 714 hours. So if we go back to our calculator here, by 24, yeah, sorry, 714 divided by 24 hours in a day, that's 30 days. So if you were to let this truck sit for 30 days, it would be at 10.5 volts, roughly. Now, that's not so bad, but let's say we go back to the calculator here and we left the door open, right? Now we're about 1.8, 1.9. So let's run that again. How long would it last with the door open? 93 hours. 93 hours divided by 24 hours in a day, it would last roughly almost 4 days. So depending on how much current draw your system has will depend on how long the truck will stay alive before it goes dead. So, I mean, just the light on, it'll last a few days, but if you have like your refrigerator left on or, you know, something else, it can be down to just a few hours before your battery is dead. So if this was my truck, I would probably go through and try to see if I could get that a little bit lower. But I mean, 30 days is pretty good without running the truck. But if you have an issue where your truck dies in a few days, hook it up just like I have here with if I'm just going to take this all apart here, just in case you don't have jumpers. We're going to disconnect all the negatives. I'm going to put my negative terminal on my lead, on my multimeter on the black, and then I'm going to put the red onto this one. And that's where I get the 0.25 number. So if you put that on there and you see a couple amps, 2-3 amps, something like that, even maybe 5 or 6, some of these bigger trucks, they have big loads. That could be a reason why well, I guess I should say, that is the reason why your truck dies in a few days. So I hope this helps. All right, welcome to the lab here. This is where we do a lot of our ECM testing, repair, any sort of fine circuitry. This is where we do it at. I just want to go over relays real quick. As we can see here, we have a pretty basic relay that's found in most automotive applications. Anything from cars to heavy-duty trucks. Pretty much this is your standard relay. Now, you can see it has 4 pins in the bottom. Some of them have 5, but this one just has 4. So the way that a relay works is it actually has a schematic on the top of it. This one does, not all of them do, but this one does. It has a switch from pin 87. I don't know how close Jordan can get in on this. All right. It has a pin on pin 87, which is the pin that's represented on the bottom here. And then it has pin 30 with a switch. And you see that little dotted line right there? And then you see pin 85 and 86. So when you put 12 volts across pin 85 and 86, it pulls that switch into there to complete the circuit, which allows power to flow from 87 to 30. So if you have, let's say you want to turn headlights on or something like that, you usually run it off of a relay. These handle more power than like a switch does in your dash. So most of the time, like your switch in your dash doesn't go to the actual headlights, it goes to a relay. The same thing with ECMs and like body controllers. They don't typically output enough power to directly drive the headlights. They usually go to relays. So if we want to test this relay to see if it's good or bad, using the multimeter here, we're going to put our black lead on common, our red lead on voltage or resistance here, and we're going to turn it to the resistance setting. Now I have a power supply here which is representing my battery. I have it set at 12.6 volts. So I'm going to put 12 volts onto pin 85. They are labeled on the back. This is pin 85. I'm going to put my negative onto pin 86. So this is pin 86 right here. Oh, as you can see, you heard it click there, right? So just hearing it click doesn't mean that it's working. You actually have to put your multimeter on to verify that it works. I've had meters or relays that click like this, but they're actually still not working. So we're going to attach the meter here. We're going to have our red lead using the jumper wires and our black lead or red lead here on the black lead. We're going to connect pin 87 and pin 30. So I'm going to put this on pin 30 and pin 87. Now we can see that we have open circuit, no resistance flowing through it. Now when I connect the relay, putting 12 volts across pin 85 and 86, you'll hear the relay click and you'll see the meter go to 0 ohms, or close to it. So let's actually go to continuity here. This little switch up here and this thing will also blink when it shows that it has continuity. So that's a short test that you can do to test your relay.
Alright.
Do you hate electrical problems like I do? All right, part 2. You have problems? Electrical problems? Frustrating? We're going into part 2.